My name is Tarass Vercesuks. As you can see in the agendas, probably met with at least some of you during the last 10 years a couple of times, because up until 2 years back I was doing pre-sales for servers and storage for Hewlett-Packard in the Baltics. Now as local offices in Estonia and Latvia were closed, so we had to change the setup of the organization a bit. So I moved to the wholesaler, but pretty much keep doing the same work, which is talking about HP servers and storage products to customers in the Baltic countries. And today the topic will be about the latest addition to the HPE storage family, which is Nimble Disk Arrays. And acquisition was completed in May this year, and some first products are available in select countries since June. Unfortunately, Baltics is not yet on the list, but we're going to get the Nimble products roughly around the end of the year in December. So it's a good time to start introducing the technology and explain what this thing is, what the technology does. So when the products are available for our partners to Santa Monica to be offered, you are pretty much aware what we are talking about. And I'm still seems to have trouble getting the picture up. So the Nimble Storage was on the market since 2007, so it's a relatively young storage company, especially if you compare it to some kind of dinosaurs of the storage market like EMC or the HP itself. And it always bore the problem and the benefit. And the benefit of all kinds of different startup storage companies is that then they do come to the market, they have a clear idea of what the current state of IT is. It's very difficult to adjust your existing product, which is established architecture, to comply with the new realities of the IT world. So a lot of vendors had to do a lot of work to play good with the virtualization, and the virtualization started to appear. And the cloud technologies came along, and then also if you have existing product, so let's move on. I was trying to yeah. That was fast.
You were faster.
Good. Let's move on. So as I mentioned, it's probably out of the whole IT stack, which is networking, server and storage, most of the challenges to adapt to the changing IT environment is for the storage. Because the storage is relatively fixed architecture for the disk array. And if the workload parameters are changed significantly, then you really have to think how your box can really be doing good. And the latest trend, what we now currently have, is that we deploy the applications in different ways. We can deploy it on premises, we can deploy it in cloud. And also, we start to work with data in a new ways. We acquire data and process the data. Typically, it may be now quite far away from the place where we do store the data. So this is create something with a bit of an issue that Nimble, as original company, identified as an application data gap. Because basically, when you are selecting the disk array, at the end of the day, you are not selecting the exact architecture. You are not selecting how many cores the controllers have or what kind of file systems they are using inside. You are selecting the technology which will give your application access to your data in a fast and reliable manner. So the data is available and is available for the application fast enough to be processed, so the users are happy. But it's not always the case. And if you have any kind of those hourglass running, and the typical reaction from the user is that application is slow, I do not like it, and in most cases, when you turn to IT, so application people come and say to infrastructure, hey, your storage is slow, we cannot get the data fast enough. So this is something which Nimble called the application data gap. Now, the thing is that, as you probably know, if you are running and supporting the storage infrastructures, it's quite often that the problem is not the disk box, the storage box itself. The problem might be anywhere in a solution stack. It might be the application, it might be the configuration of the host, it might be the networking. Roughly half of the situations, the problem is outside of the storage. Yet it's treated kind of, and we see it as a storage problem. And these are some typical issues that some of you might have encountered during your daily work, and then you try to pinpoint and find the root cause of an issue, because it's not that easy to identify upfront. So your hosts are losing connections to your data volumes periodically, or there's some high latency in a certain periods of time, or just application I/O slows down. You probably can extend this list. It might go on. And what's in common for all of these issues, but you cannot say exactly right at the moment you see the issue and you say, oh, I know, that's the reason, I know how to correct it, and I will do it like this. So how do we try to solve this problem typically? Well, the storage vendors are guilty of the first thing. They come to you and they say, your database server is slow, we're going to sell you a new flash array. It's flash, it's fast, so you just buy the flash array, you move your database to the flash, and everything turns like this. All your problems will go away. Another approach might be, somebody might tell it might be some hyperconverged vendor, which says that the issue is you're running the slow, outdated legacy hardware, which just cannot cope to support new virtualized infrastructures. You have to buy a hyperconverged box, which is all integrated, everything is gelled together, data is very close to the application, the issue will be resolved. And then something what most of the developers nowadays do is say, okay, let's just buy everything from the cloud, because the local guys cannot sort this issue for you anyway, so let's buy some Amazon stuff, and it's going to be cheap, it's going to be fast, and you do not have to worry about the infrastructure at all. And sometimes it works, all of these approaches, sometimes it doesn't. And probably as being involved with quite a lot of storage cases, I had more than one case when the buying flash storage did not resolve the problem, because the storage was fine. It was the application, it was some specific of the setup or the missed best practice in configuration, which was slowing down the app. So you just spend some 5-6 figure budget on buying flash storage, you install it, and your application kind of speeds up, okay, by 10%. Seems quite bad, and then the IT department at that moment probably is not at a very good place. And think of the hyperconvergence in and in cloud. So they do cover most of the stack, but if things go bad with this stuff, they go really bad, because it's pretty much black box appliance. You have to rely on the original vendor to try to solve the issue, because the troubleshoot inside the appliance or troubleshoot inside the cloud is not very easy. So in some cases, you might not solve the issue with going with this. And what Nimble was thinking is that we see that in many situations, the problem is outside of the box. What if we try to help customers resolve these issues for them, even if it's not the storage problem? How we can do it? One of the things Nimble does is all of the Nimble disk arrays out of the box are enabled for the telemetry, which collects a lot of data points. And there is nothing unique about it. Everybody in the storage market does it. All disk arrays nowadays are capable of sending call-home information to the vendor, telling something about what's going on in the box. So what's so unique about that approach? But what most other vendors do, in best case, what you will get out of this telemetry data. So the array can say, oh, the disk has failed, and the vendor will send you the new drive to replace it. That's pretty much what everyone does. And the worst thing is the situation has not changed over the last 20 years probably since this stuff was initially introduced. So what Nimble does, Nimble applies the machine learning technologies across all of the collected telemetry data from different customers, what they have. And they run cloud service which basically provides the customers with predictive support based on these machine learning technologies. So there are three very important parts of this. They do collect heck a lot of the data. They do run machine learning on top of it. Basically, what they have done, they have built the very big data. They have built large big data environment, which they use to improve the experience for their customers available as a cloud application. So this is the trick. And this telemetry data covers all of the stack as much as they can gather. So they built into the array firmware capability to collect as many data points as they can get hold of from the networking part as well, from the storage fabric, and also via the APIs from the hosts that support it from the operating system. So they can cover not just their storage box, they can cover your whole IT stack from the host to the storage. And it's made available to the customer via something that they call InfoSight portal, which is basically the web portal for you to access this information. But it's not the thing that they give you access to the information. What they are capable of doing by utilizing this stuff is goes beyond just displaying customer the information. Just to stress once again how they are different from another vendors. During the 4 hours, Nimble collects from their installed base roughly as many data points as there are stars in a galaxy, which is 100 billion. And for the second, this is as much data as any other vendor have not yet collected since they implemented their telemetry solution. In just 8 hours, Nimble collects more data than the EVs have collected for all of the time of its existence. That just gives you the scope and the breadth of the data they operate with. So what the benefit is for the customer? Okay, so these are very cool guys. They collect a lot of data about my storage arrays. So what, you might ask? And this is so what. So there are 7 unique features for the Nimble customers, which are enabled but utilizing this infrastructure. First, and the most important goal of all of this stuff is to prevent downtime. So they constantly analyze the collected data. They see if some guys are having some problems. They find another arrays which have the same setup, which have same firmware, which are talking to the same operating system. And they predictively apply the fixes to those arrays to make sure that the downtime is avoided altogether. In case the automatic patching or correction is not possible, they at least can provide the customer with the preventive scenario. So, hey, Mr. Customer, we cannot do it for you remotely, but here are the steps you have to do to correct the issue. And if you will follow this instruction, then you will get to the right result. Then there's prescriptive resolution. So if it cannot be done without some changes to the product, for example, they analyze if your workload will keep growing as it is growing now, you will run out of the controller resource in 3 months. So they will inform you. So either scale down and redistribute the workloads or upgrade the controllers because you might face the performance issues in 3 months' time. They give you directed root cause analysis, again, just because they collected all of the data stack from the virtual machine down to the storage array, which gives the capability to very fast and accurately actually pinpoint you to the exact place in your infrastructure which is causing the problem. So if the problem is outside of the Nimble control altogether, if it's the problem with your host on operating system, they can at least tell you that, and they also inform the vendor of the respective product to apply the corrective measures. By doing this, they significantly streamline the support experience for the customers. So one of the things Nimble is unique in the industry about, they do not have level 1 and level 2 support. So you do know probably how level 1 support means. Hey, Mr. Support Engineer, I'm having issue with my disk array. Yeah, good. Please collect these log files, please collect these log files, send them to me, and please fill in this form, describe exactly what you are experiencing, we will try to recreate it, blah, blah, blah. Because all of this Nimble InfoSight infrastructure, you do not have to do this at all. You do not have to call and talk to the guy about something you need to collect because the data is already collected. And if you have to make the call to the Nimble support, you will be talking. If you really hit the problem hard enough that is unique and the first in the world, you are so unlucky, and you have to call to the support, you will speak directly with the level 3 engineer. And typically, it will take less than an hour to at least resolve the issue or identify the problem of an issue. So there are no level 1, level 2 support guys which are just wasting your time at the moment when you really need fast resolution. If the problem is really that bad, then you will be talking to the guy which already is capable of doing all of the needed escalations and technical work. And finally, because all of this is collected and analyzed, the availability data of their product that the Nimble is reporting, they are not theoretically calculated based on what the components are. So if we take this disk, it has this MTBF. If you want to take this controller, and all together we provide you 5.9 availability, which pretty much for all of the guys means nothing but the numbers in the datasheet. For the Nimble, when they report their availability numbers, it is calculated from the real data in their support portal. So they know exactly what the availability of the environment is from all of their joint customers. So when the Nimble says we have this availability number, then you really know that it's based on real data. Some examples of how this thing works. For example, Nimble InfoSight detected the restart of the controller. Well, the hardware with the redundant controller, of course, handles the failovers, so there's no real performance impact. But again, the issue is momentarily noticed, analyzed, and all of the customer demographics is analyzed, and they find that the systems which need apply the fix is developed and sent automatically to the systems to prevent the same issue for another customers. Or some other example, the VMware host suddenly experienced a high latency across all of their applications. Again, it's seen through a lot of different customers. 600 systems are identified that fit this bill, and they see, so there's something in common with all of the systems which have this issue. They all run AS6 of particular version, they all run iSCSI, they all run particular version of the Nimble firmware on the disk array. So they develop specific fix for that, and they list these 600 systems. So these 600 arrays, the only thing they can do now is apply the certain patch which is developed. You cannot do the downgrade, you cannot do the other upgrade before you actually apply this patch. So that's something that they call blacklisting, making sure that all of the actions which might get the situation worse or do not apply to correcting situations are not recommended for these arrays. And don't worry, this is not something that happens absolutely without your knowledge. Everything is also available for your information as an email alerting or via the InfoSight portal. So all the information is visualized. You get all of the dashboards, something that you can show to your manager to tell about our capacity growth trends, performance growth trends, and also all of the statistics information which is available to you as an administrator. Available globally from anywhere in the world, you can see how your Nimble infrastructure behaves. And as I mentioned, it goes beyond just the storage. For example, via the vSphere APIs, the Nimble has the VM Vision component to the InfoSight, which displays you a lot of very useful information about your virtual machines. Like what is the latency of the virtual machines, what are the capacity growth trends, what are the performance hotspots, so you can see actually up to the virtual machine layer how the performance of the storage affects your applications. If it's latency, you can analyze what contributes to that latency. Is it host latency? Is it storage latency? Is it network latency? And also you can have the picture of all your virtual machine demographics to see maybe you have to redistribute, re-optimize your workload. And the predictive guidance regarding the upgrades, capacity upgrades and the controller upgrades. You get all of this trends information into the InfoSight portal. So the Nimble will tell you, so again, if your workload keeps growing like that, you need to upgrade your cache in 3 months, or you need to upgrade to the up controllers in half a year. So you get this information well in advance in order to plan what you're going to do. Either you plan to upgrade or redistribute your workloads in your infrastructure, but you won't hit an issue that one day you come to your work and then realize that suddenly your latency just up like crazy because the system slowly have run out of the resources. So that makes all kind of planning much easier. And the result of this technology is that roughly almost 9 out of 10 support cases are opened and closed, resolved automatically. So you do not have to do anything in order to maintain your and support your storage environment in 9 cases out of 10. The currently measured availability is above 6/9 of the installed Nimble customer base. And more than half of the support cases that the Nimble engineers are solving actually do not relate to their disk arrays. But instead of telling you, hey, go speak to the Microsoft, it's their issue, they actually tell you what the issue is and at least inform also the Microsoft or the VMware or the Procade that they have some issue to fix. So, and it doesn't cost you anything extra. That all Nimble arrays out of the box are InfoSight enabled as long as you have warranty or any kind of support for that. So that's not a special license to buy. And that's the reason why the HPE was looking at the Nimble, because otherwise, well, that's just another storage box. It has its specifics. We're going to cover a bit of what the product looks like and does, but the actual benefit and kind of one of the most interesting part is this automated InfoSight support and customer environment, which really helps you run your storage infrastructure and concentrate on some other things to do. And this technology can be easily extended to cover other parts of the storage portfolio that HP has. And the first will come along the free part boxes, which will be added to the InfoSight until the end of the year. So that's certainly going to be extended also to other products. Moving to the product itself. So the Nimble arrays, they have currently 3 series. 2 of them are meant for your production data as a primary storage, all-flash series, and adaptive for basically hybrid arrays. And there's also a new, quite interesting product which is called secondary flash arrays. That's an array that you can use mostly as your backup or replication target, but at the same time also run your production workloads and benefit from the Nimble architecture. All-flash, of course, is for the situations when you want absolutely high performance. Adaptive series is cost optimized, and secondary flash arrays is pretty much quite a new category, and other vendors do not have that approach. It's not that it's technically somehow unique, it's just the way it's utilized is not very common up until now. So the flash arrays, dual controller support scale up and scale out. The Nimble arrays are always, the performance factor is the controller. And it is supported to upgrade the controller. So you can start with the smallest model, which will be roughly about up to 45,000 IOPS, and go all the way up to 350K IOPS just by swapping controllers. The upgrading controllers is online operation, completely supported, and that's not something that the HPE, for example, is doing with the FreePars. With the FreePars, controller upgrades are not available, not part of the strategy. With the Nimble, it's a normal way. You can start with the lowest model and then gradually go up if you need so. But if you decide that the better way won't be to swap the controllers for the existing array, you can do the scale out. You can create the cluster group out of up to 4 arrays and manage them as a single entity and either stripe the data across them or move the data, move the volumes online between them. So that, and you can do both at the same time. So both scale up and scale out approach. Nimble has very efficient approach to the storage capacity. No write groups for you to design. Write configuration is pre-created. It uses triple write plus, which means that there are triple parity write, and also the data on the disk itself is protected by the checksum. So both inter-disk and intra-disk data protection, and triple write is applied to the set of the roughly about 20 drives. So you get very, very efficient usable capacity, something above, much above 70%, 75% is typical. And this is very good ratio, even considering that this is triple write. Many other vendors with double parity write getting much less data efficiency. And on top of that, you can add the inline deduplication and inline compression and the zero elimination, which is always on and enabled for the whole capacity. So that provides very good capacity efficiency on Nimble arrays. So this is what you get with the Nimble box. Again, the Nimble's configurations are typically very, very simple. You have the part number for the base model, you have the part number for the capacity pack, and you have part number for the cache item, which basically 3 part numbers define your Nimble configuration. No licenses, no InfoSight licenses, everything else is pretty much bundled into the price of the product. So we get the 6.9 availability, the efficient capacity, integrated snapshot and replications, and this encryption option all included with the product. The hybrid arrays operate a bit differently because they have the SSD cache and then the big capacity of the nearline drives. The SSDs are only used for the cache, and for each volume you can decide what would be the mode of the cache. Are you trying to get most of the volume data into the cache if it's your critical application? Are you trying to minimize it if it's some kind of low priority stuff, or you just let the array decide how to do it? You can pick it per volume. Again, same scale up and scale out approach. You can do upgrade by switching up the controllers, or you can do the clusters of up to 4 arrays. All the same data services, so you get your replications and the snapshotting and the zero space clones. The trick how Nimble still provides very high performance with the nearline drives in the hybrid arrays is very simple. They have something which is called Castle Cache Accelerated Sequential Layout. Basically, when the hosts are doing writes to the Nimble array, the writes are assembled in NVRAM into the 4 to 10 megabyte stripes. And you write to the disk arrays themselves only these big stripes. As a result, the I/O you do to your disk backend is roughly 10 times less than the I/O that the host does to the array. So you can be very efficient with the even nearline drives on the background. And in order to accelerate the reads from that array, you have SSD cache. Because all of the data is written to the nearline level, and the SSDs are only used for cache, there are no write on the SSD, so you have a lot of capacity available, maximum that you can get. Because it's sequential layout, the endurance of the flash media can be very efficiently managed, so we can efficiently use 3D NAND drive. You do not have to settle for the expensive MLC enterprise drives. And typically, the Nimble arrays with roughly up to 10% of the cache capacity will see something like 95% of the cache hits. So that's because of an architecture and the capability for you to also adjust the caching policy for particular volumes. So replication is available. As I mentioned, you can either create a scale-out cluster on a single site, or you can do replication across the IP or the FC links. to the secondary side, and arrays do not have to be the same. So you can have the all-flash arrays as a primary, and you can have hybrid as a secondary array, or even secondary flash array, which we're going to talk about in a minute. So the secondary flash. The idea of the secondary flash is to have the array which can serve you both as a backup, disaster recovery, and low priority production box at the same time. On the primary storage, the deduplication is only available on the all-flash models. Hybrid models do not do the deduplication because it's an extra workload it puts on the controller. With the secondary flash arrays, it's basically flash hybrid array where you can also do the duplication. So when you use it as a backup target, it provides a very good capacity efficiency. But because the same Nimble adaptive array with the SSD cache, when you need to start something from your backup, like instant VM recovery, or when you need to fail over to it and start your disaster recovery site with some couple of virtual machines, you get really flash accelerated performance out of this box. So this guy combines the capacity efficiency of the typical backup appliances like HP store ones with the performance of the hybrid disk array. So you pretty much can combine your backup target and your DR target, and also run some kind of development workloads on this box at the same time. Yeah, currently the first reference architecture for this approach is developed with Veeam, but Nimble is also working to enable other vendors to have recommended setup for this configuration with Commvault and backup exit, etc. Finally, what if you still want to use some cloud services? And there is one thing which Nimble is currently testing in US, but it also comes to Europe, which is called Nimble Cloud Volumes. Basically, what Nimble did, they installed some of their arrays to the Amazon and the Microsoft Azure data centers and created the portal for you to just buy the virtual volumes from this array. The benefit, comparing to just buying standard volume, is that it's fully functional Nimble volume. You can have all of the InfoSight benefits for it, and you can manage it from the same console that you manage your local storage. So we can have on-premises array replicated to Nimble Cloud Volume in Amazon that your Amazon virtual machines can use, manage from the single console and do the replication with the standard Nimble tools, and have all of the benefits of InfoSight for these cloud volumes. So Nimble native, run on Nimble hardware, just installed to particular data centers and made available for particular compute resources of these service providers. And you can order it the same way that you order virtual machines from the service provider just via the portal. You do not have to buy them separately from some other source. So it's just cloud portal as it should be. So you can buy it and you can increase it, you can take it down, just the way you are buying the resources from any of the service providers. So this is it about Nimble technology. Introduction to the storage technology itself, primary flash array, secondary flash arrays, and Nimble Cloud Volumes, all covered by InfoSight Predictive Analytics, which makes really unique support experiences. This is one of the main reasons why the Nimble customers are so pretty much in love with their product. We do not have any Nimble installation in the Baltics. We have not been very active here, being mainly US company, and also in the Europe they mainly have been in the big countries like Germany and UK. But our our HPE colleagues from other countries told that when they lose deal to the Nimble, the thing is that you can be better technically, you can be better on pricing, but you cannot beat this thing with any other stuff that you can offer. So that was typically one of the most important reasons that the deals have been lost to Nimble. So instead of competing with them, HPE decided to buy them. So they are fast, they are very simple to run, and you can concentrate on the other things you do, and they have cool integrations into the cloud. seems like very interesting product. I cannot wait until we get a hands on them. We get first demo systems probably towards the end of the year. So if you are interested to see more of this stuff, just talk to Santa Monica. I believe we will have some units to test and look at by the end of the year. Questions? Yeah.
It seems to overlap a lot with the features of FreePod. So what's the plan with this? Is it gonna catering the same enterprise markets, or FreePod will be more like enterprise?
There are two answers to this. One is the one that the HPE typically gives, and the second is my opinion how it's going to look. The HPE answer is that even if you look at the performance numbers, like the Nimble scales up to something like 300,000 IOPS. And this is something that you can do even with the smallest FreePod box. So performance-wise, the overlap is not that big. Feature-wise, especially on the high availability side, FreePod is much more capable. Much more replication scenarios like free data centers, active-active peer persistence scenarios, that kind of stuff. So from that perspective, this slots roughly a bit below the FreePod, with the main focus on the ease of use, usability, and being simple to run, which is, FreePod is not also very complicated box to run, but it still requires more administrative involvement to do it. That is kind of official positioning of the two products. And FreePod remains so-called hardware-defined product. Each FreePod controller has special proprietary HP developed ASIC for the acceleration. This guy is built on standard x86 box, so at some point we might maybe even see the virtual Nimble. Something what I see, how the positioning will go, and this is no way related to what HPE can confirm at the moment. From what I understand, the next generation of FreePod will get rid of the spinning media altogether. It will be NVMe plus SSD, probably something going up to 5 million IOPS. So that will probably move a bit up into the really low latency, flash optimized high performance space, and the Nimble will take some part of where we do currently offer FreePod in a lower segment. But do not ask it again from HP, they won't confirm it. Yeah. No other questions? Thanks a lot. Sorry for the technical issues at the start, and I also stole 10 minutes from your lunch already, or 15 minutes.